So I'll talk about electrolysis of concentrated hydrochloric acid. So we said the first step is splitting of ions. The ion splits, okay, into hydrochloric acid split into hydrogen and what? And chloride what? Chloride ion, right? And of course, you are going to have water too, splitting into hydrogen ion and hydroxide ion, right? Okay. Then the next thing
Okay, sir.
will be migration of ions. And the migration of ion is dependent on the fact that unlike charges what attract. Unlike charges attract. Okay. So then we have the cathode and the anode. So now let them migrate. We find out that you have hydrogen here and hydrogen here. So hydrogen ion is the only ion that will migrate to the cathode because unlike charges attract, positive ions will be attracted to the negative what? Negative electrode. So that's where hydrogen ion comes here. Then for the anode, you have your chloride ion and your what? Hydroxide ion. So both of them, chloride and hydroxide, migrate to the anode. Okay, so since we have two ions migrating to the anode, okay, there's going to be competition between the two of them, competition between the ions. Okay, now let's look at the cathode first. The cathode here, it's only hydrogen that migrated there, and so we have this reduction half equation taking place here, reduction half equation taking place, and here we have the oxidation half equation taking place at the anode. But the question is, why was chloride selected? Chloride was selected because this is electrolysis of concentrated what? Hydrochloric acid. So it means that concentration took a upper hand over what? Over hydroxide. Okay, because hydroxide is lower in the reactivity series than what? Than chloride. So ordinarily hydroxide would have been discharged. Okay, hydroxide would have been what? Would have been discharged, but in this case, because chloride is concentrated, it is the concentrated halide that will be what? That will be discharged. Okay, so where chlorine is discharged here is going to lose electron because at the anode you have what? Oxidation, and oxidation is a loss of electron. So, and I said, based on the two half equation that we have, let us look at the diagram for electrolysis using the Hoffman's what? Hoffman's apparatus. Okay, look at the diagram for the electrolysis using the Hoffman's what? Apparatus. Okay, so if they
Okay,
label
sir.
this A and B and they ask you the question, in the electrolysis of concentrated hydrochloric acid, what will be you know that hydrogen and chlorine will be discharged, okay, as gases. So where will hydrogen be formed? Is it at A or at B?
So it will be formed at B.
Okay, it will be formed at B. Why? What gave you that hint that it will be formed at B?
So because at B is where the cathode is.
Brilliant, because it is negative what? Electrode, right?
Yes.
It is negative electrode, so it will be formed at B. So your hydrogen will be formed here, while your chlorine will be formed what? Will be formed here, right?
Yes.
Okay, so that's another way. Let's look at another way they could ask you questions around that. Okay, they will not label this as cathode or anode. Okay, they won't label it as cathode or anode, but they will ask you questions around observation form. They will tell you that at tube, let's say at tube A, okay, let me twist it now. At tube B, at B, they notice that a greenish, okay, a greenish yellow gas was formed. A greenish yellow gas was formed at what? At tube B. So they will now ask you, okay, which of these is the cathode, X or Y?
Um. So be
Which
X.
X is the what? Cathode.
Is yeah. No,
Oh,
yeah.
why did you say X is
No.
the cathode? Why?
So won't X be the it be the I I I know it because that's where chlorine is.
Exactly. So this will be the anode. Why? Y will be the what?
Um cathode.
Cathodes. So can you see the way they could ask questions? Various way they could ask what? They could ask you questions based on the knowledge of electrolysis. Now they did not tell you which one is positive, which one is negative. They only told you that an observation was 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 found at what? At B. They noticed a greenish yellow gas formed at B. So they are not asking you which of these is the cathode, X or Y. So you just transfer your knowledge to be able to answer that question. So at the cathode will be the what? The negative electrode, right? So if chlorine is formed here, because chlorine is that greenish yellow gas, chlorine would have been formed at the positive what? Electrode, which is the what? Which is the anode. Do you understand this
Mm,
twist?
yes.
Okay. So let's look at the third twist they can bring in here. The third thing they can bring in. So they now the third one they could bring in here will not actually differentiate the two of them, and that is the level of the water. Because if it is acidified hydrochloric acid, you have hydrochloric acid here, okay, in the tube. That's your electrolyte, okay. This Hoffman's apparatus. So they pour in the electrolyte through this place. They pour it in. So when they pour it in, it's going to fill the tube, okay, and they will lock this tap, this place. They will lock it such that the gas will not escape. So usually it will get to the brim, okay. Now when the electrolysis takes place, when the electrolysis is taking place, the gases will be formed, okay. Gas will be formed inside this what? Inside this electrode, okay, at this tube, the tube here, the arm of the tube. That is where your gases will be collected. But if you look at this space, the space above here tells you the volume of gas collected, okay, the volume of gas collected. So if this is positive and this is negative, then it means that this will be the volume of chlorine, while this will be the what? The volume of what? The volume of hydrogen collected, right? But if you look at these two, the two levels are the same, isn't it?
Yeah.
They are the same, right? So that tells us that let's write the equation of what happens at the cathode. It is H2. Okay, sorry. What happened here is hydrogen ion 2, okay, aqueous is going to gain 2 electrons to give you what? To give you H2, okay, gas. The same thing with chloride ion. Chloride ion aqueous, okay, 2 of it is going to lose 2 electrons to form what? To form Cl what? Cl2 what? Cl2 gas. So you can see here, look at the amount of electron lost or gain. Are they the same?
Um so yes.
Okay, the amount of electron loss and gain is the same. That is number one thing to look at. Then what about the mole of gas form? Here you have 1 mole of chlorine, isn't it?
Yes.
And here you have 1 mole of what? Hydrogen. That tells us
Yeah.
that you have equal volumes. Equal volumes. Can you
Yes.
see that? You're going to be having equal what?
Yeah.
Equal volume. Okay, good. So we have been able to look at if you have different moles of electrons in the equation, then you are going to have different volumes. We are going to see how that plays out in the next electrolysis, which will be the electrolysis of what? Of dilute sulfuric acid. Electrolysis of dilute what? Sulfuric acid. Okay, so we have seen the electrolysis of concentrated acid, how it looks like. So let's look at the electrolysis of dilute what? Sulfuric acid, and we'll use that to explain how the volume of gases formed can help us to identify which one is the anode, which one is the cathode, where oxidation took place and where reduction took place. Do you get that, please?
Yes, sir.
Okay. So let's now look at electrolysis, or that will be our B, electrolysis, electrolysis of dilute sulfuric acid. That this is very key, very important. Dilute sulfuric what? Sulfuric acid. So the first step here will be splitting of ion. Okay, the ions what? Ions will split. Okay, so what are the ions present here? We have sulfuric acid H2SO4. Okay, aqueous is going to dissociate into hydrogen ion and what? Sulfate what? Ion.
Um,
Hydrogen ion and sulfate what? Sulfate ion. And of course, we also know that water is there, H2O. Of course, if you like aqueous, okay, it's going to split into hydrogen ion and what?
so,
Hydroxide what? Ion.
good. Yeah.
So now, number two, the second thing that's going to happen is what? Migration of ions. Migration of ions. The ions will migrate. So we have the cathode, okay, your negative electrode, and the what? And the anode, which is your what? Positive what? Electrode. So migration of ion. This will migrate, okay, to the negative, okay, while these two guys will also migrate to the what? To the anode. Why would that happen? Unlike charges what? Attract. Okay. Unlike charges attract. Okay, that's a simple principle. So now let's get to the cathode. Cathode will not be difficult because it's only what? Hydrogen ion that migrate to the cathode. Okay, hydrogen ion that migrate to the cathode. And so when it gets to the cathode, the next thing is it's going to be discharged. Discharge. That is the third thing. C, which is what? Discharge of what? Of ions. Discharge of ions. Ions will be discharged. So now, what happens to hydrogen ion at the cathode? Remember the crow. Crow tells us that we have what? Cathode is reduction, anode is oxidation. Cathode is reduction. A reduction is what? The loss of electron, oil rig. Okay, oil rig. Reduction is the gain of electron. Pardon me. Reduction is the gain of electron. So that means your hydrogen ion is going to gain electron. Okay, each hydrogen ion gains one electron to form, okay, hydrogen gas, because hydrogen is a what? A diatomic gas. So I'm going to multiply this by 2 and 2. Okay, this is what happens at the what? At the cathode. Okay, at the cathode here, hydrogen gas is discharged. Hydrogen gas is discharged. Now let's go to the anode. At the anode, two ions will migrate there: hydroxide ion and what? And sulfate what? Ion, right? So because you have two different ions at the anode, there's going to be competition among the ions. There's going to be what? Competition among the ions, meaning that the electrode will now uh, preferentially choose one of the ions to discharge. That is what we call the preferential discharge of ions. The preferential discharge of ions. Okay, so what is going to affect the discharge of ions here? There are three factors that affect the discharge of ions. The first one is called the nature of the electrode. The second one is called concentration. And the third one is called, uh, we, uh, we said nature of the electrode, concentration, and the third one is position of the ions in the reactivity series. Position of the ions in the reactivity series. Ions that are lower in the reactivity series are preferentially discharged. Ions that are concentrated, more concentrated, are usually preferentially discharged. But in this case, now we are dealing with dilute sulfuric acid. Dilute sulfuric acid. Dilute simply means that you have more water than sulfate. So if you have more water, it means you have more hydroxide ion. So based on concentration, hydroxide ion is favored because this is dilute. So it means that you have more hydroxide ion. That is on one hand. On the second hand, hydroxide is lower in the reactivity series than what? Sulfate. You can see sulfate is far way at the top, hydroxide is lower. So you find out that two factors favored the discharge of what? Hydroxide: concentration and position in the reactivity series. So that means that hydroxide is favored for what? For discharge over what? Over sulfate. So hydroxide is going to be discharged at the anode. Do you get that?
Yes, sir.
So when your hydroxide is discharged, what's going to take place at the anode? Anode crow. Ow. Anode is oxidation. Oxidation is the loss of electron. That tells us that hydroxide ion is going to lose what? Electron. So, but when hydroxide ion is discharged, okay, practically it produces water and what? And oxygen. When it is discharged, it produces water and what? Oxygen. So in order to be able to produce water and oxygen, we are going to be needing 4 hydroxide. It means that 4 electrons will be lost. So it's going to produce 2 water and 1 oxygen. Okay, you can see that hydroxide is discharged. 4 hydroxide will lose 4 electrons to produce 2 water and 1 what? 1 oxygen. 2 water and 1 what? 1 oxygen. Okay, so it means that your oxygen is produced at the what? At the anode, while your hydrogen ion is produced at the what? At the cathode. Okay, so
Okay.
let's now apply the theory of the Hofmann's apparatus that we discussed earlier to this particular word, to this particular equation that we just looked at. Let's ask the same questions we asked at that time, okay, to identify where your cathode is, where your anode is, and so on and so forth. Okay, so let's still use the diagram of the Hofmann's apparatus. Okay, so let me use the diagrams. Okay, so that means this is now for electrolysis of dilute what? Electrolysis of dilute sulfuric acid. So we have our electrolyte inside. We have our electrolyte inside, and this is labeled as A or what? B. Okay, this is A, and this is what? This is B. Okay, so now let's ask the same question we have been asking all this why. For if they label this particular um place as positive and this as negative, and they're asking you for the electrolysis of dilute sulfuric acid, they're asking you where will oxygen be formed. Where will oxygen be formed? So is it at A or B? Where will oxygen be formed? At A or at B?
So will it be at A?
I want you to answer.
Let's say at A.
Final answer.
Yes.
So why did you choose at A?
Well, sir, um, because A is where the cathode is, and since sulfur and oxygen are positive, they won't be attracted to the anode.
Okay, you said this is negative electrode, is your cathode. Yes. Okay, so will oxygen be formed at the cathode?
Yes.
Okay, what will be discharged before oxygen is formed. Which ion will lead to the formation of oxygen?
Um, sulfur.
Go back to this. Can you see?
Yes.
When your hydroxide is discharged, it produces oxygen.
Oh,
Hydroxide is discharged. This is dilute. Sulfate is not discharged. Sulfate will remain in the solution. Sulfate remains in the solution. So in this case now, your hydroxide is discharged and it produces oxygen. So hydroxide is negative ion. So where do you think negative ions will migrate to? Will it migrate to the cathode or to the anode?